Welcome back, my ladies and gentlemen, boys and girls, friends and acquaintances, to Gabversity. L. Brooks, congratulations, you got the yeah. Where facts care not about your feelings, Deltron and L. Brooks and Gab smacked. So we're going to show you completing the square. This is a simple concept. It looks tricky at first, but it's a quite ingenious way to help make problems a little bit easier. Have a look at this. All right. Imagine that you want the area of this weird shape. All right, now how would you do that? Let us zoom in. Well, you'd have to find the area of this section, and then this section, and that section. You have to find the area of 3 sections, right? Or you could do a rectangle and a square, but still, a rectangle is hard because you've got to find multiple sides. So that's one way. There's another little tricky way, right? Which is this. You get the whole square, and that's the part missing, so you remove that part, and then you'll end up with the same thing. Now, clearly that's not drawn to scale, so forgive me. Okay. Now, why is this way easier? Why is it easier to get the whole square and then take out a bit instead of getting all these little squares? It's easier because, as a rule, a square can be represented by its side. Did anyone know that? This is we're squishing down information to make it easier to compute things, because computation, right? You need an infinite amount of computation to solve all of the problems, less steps, exactly. And by reducing that, it reduces the computation difficulty. Okay, so here we go. So this is a side, okay? Now the square, right? An area of a square can be represented by the side squared. Right? How easy is that? So you don't need to have all of the dimensions of the square, you just need one side and square it. Now that's beautiful. And this comes back to what I'm going to show you now with integration. Imagine you have this equation. Here is an equation. The equation is negative ax, all right, squared plus bx. All right. Now this equation is harder to work with because it's like a, you could imagine it as the equivalent of being this sort of weird shape, right? Something like that, right? So you want to find the area of this. But what we do is we can complete the square and then take away the difference. And I'll show you how we're going to do that. Have a look at this, right? We know that in like sort of mid school, mid to high school, what do you call it? Like 8th, 9th grade or 10th grade mathematics, you know that the square, right? So the side looks like this. It looks like x, right? ax plus b all squared, right? So that is the side. That is one side. It's represented in maths by this equation, right? And anyone knows that because this is a line, right? If anyone's done basic maths in high school, that is the equation of a line, all right? So y equals mx plus b, that's a line, okay? There is the line. And it's that squared. All right, so for example, I'll show you. If we were to make a graph, that's y, that's x, okay? And, let's say ax plus b would be something like that, right? It would be a line there. So if you were to square that line, well, then you get a square, right? And that's obviously not to scale. Okay, so that's what we're doing here. Now here's the thing, watch what happens when we expand this. If we expand that, which equals ax plus b multiplied by ax plus b, that is going to equal a squared x squared plus 2axb plus b squared, right? So there you go. But have a look at that, and have a look at that. Sorry, I made that a minus, should be a plus. Okay, look at that, and look at that, what's missing? Oh, and that's also wrong. Okay. Have a look at what's missing. And I'm going to simplify it even further by putting a 2a here. All right, that and that, just to make it easier for the maths, but it works both ways, right? But this is easier to show you guys. A squared x squared plus 2abx. Have a look. A squared x squared plus 2abx plus b squared. So the b squared is this missing component. So what we do is we can now define this via this perfect square minus this. Okay, so watch this. right, I can now say that this thing, right, equals ax plus b all squared minus b squared. Right? Did you see that? So now I have converted this, right, this into this, which is basically the whole square, take out the small section. How much easier is it to work with that? It is so much easier. Look, that equation is so much simpler. I saw YouTube, incredible story. Oh, thank you very much. I'm honored, man. Thank you. Yeah, fingers crossed we'll get it out there, my friend, to help others. That's the whole plan. Otherwise, I wouldn't waste my time. I'd go sit in the bush somewhere and relax. All right. Now, why is this important? This is important because of this. Imagine you want to find the integral, right? Let's say that you have an integral. And the integral is this. You want to go minus infinity to infinity. This is for quantum mechanics, obviously. Of e to the a squared x squared plus 2abx dx. Do you know how hard that would be to integrate? Because that, right, that here actually equals this. Right? It actually equals e a squared x squared multiplied by e to the 2abx. Right? So you actually have to integrate something cross something else, and you're gonna get all this multi-dimensional stuff, and it would be almost impossible to solve, right? Unless you've done like freaking doctorates in mathematics. So it's quite simple. What you do is, using the complete the square method, instead of integrating this thing, we integrate the whole thing and then take away a bit, and that's the beauty of it. So have a look, right? That, right, as we said, equals this. All right. So now we can do this. We can say that equals, right, that equals the integral minus infinity to infinity of e to the ax plus b all squared minus b squared. Now, why is that easier? Well, look at that. Now there's no x, there's no something x times something x. It's just one thing, and then this times just by a number. So you can take that number outside. All right? So you could actually convert this to this, right? Which equals, right? It equals this thing outside. So e to the minus b squared. E to the minus b squared outside minus infinity to infinity. Okay, if e to the ax plus b all squared. Right? Now, dx. Hey, cyanide is back. Now, there's a reason, my dear friend, that this is important. Because look at this. Oh, no, don't call me. Oh, I'm getting a phone call. I don't know who it is. I'm going to ignore it. Bastard. Go away. Now everything's going to be delayed now whenever someone calls. Alright, so now look at this, right? We have shrunk this ridiculous integral, which almost no computer could solve. Hey, Muhammad, welcome. Right? We've reduced it to this tiny integral, right? And it's the same thing. It's crazy. It's absolutely crazy. Right? So what is the point of that? We'll have a look at this now. How do we make this even simpler? Let ax plus b all squared equal y squared, right? And so therefore y equals ax plus b, and this is important because we need to change dx. Now, if you guys remember, I said this yesterday, right? Where we know the speed, right? Dx is like the analogy of speed over the distance, right? So x would be the distance, dx would be the speed, right? So we know the speed of how x is traveling, right? So let's say x is cyanide, right? So cyanide is driving down the freeway, and who's one of our other top guests? Scott. And Scott is driving a pickup, right? So cyanide is driving at 60 miles an hour, and Scott is driving at 55 miles an hour, right? And you can call cyanide X if someone's trying, and then you can, and Scott can be Y. Now what you want to do is find out what Y's speed is relative to speed X, because that's part of the equation. We need to know the speed. So if cyanide is traveling at 60, right, that means that Scott's speed is 55, exactly 55 divided by 60 of cyanide speed, which means that if cyanide speed is dx, then Scott is 55 over 60 dx. So dy equals 55 over 60 dx. In other words, Scott's speed is 55 over 60 cyanide's speed. That's all we're doing, right? So basically, we're going to convert the dx into dy. So we know y equals ax plus b, which implies that dy is going to equal a dx. So therefore, dx equals 1 over a dy. That's it. That was just some basic algebra there. Frickin' zoom back in, biatch. There we go. Alright. Way more easier than it is. Well, if you know algebra, then the concept is really simple. It's just that teachers like to scare people and make it harder than it is, really. But it is really that simple, seriously. If you know algebra, then you can calculate that, but it's, as I said, it's basically, we can see that the speed of cyanide is 1 over a, the speed of Scott, or Scott's speed is a times the speed of cyanide, which a could be anything, could be 55 over 60. Engineer school flashbacks. Yeah, no, that's good. It's a shame that they don't explain it that way at school. It drives me nuts. But I think actually my autism helps because I had to learn how to understand humanity by using these analogies. So what I do is when I teach maths, I use reverse analogies to convert maths back into reality. Whereas I had to use maths to understand reality. Oh, algebra is your best subject? Then yeah, you could smash this easy. All right. So now what we have done, we can make this equation even simpler, right? So now we can say, let me put it on this page, sorry. Well done, that's exactly right, my friend. All right, so therefore, right, the integral, so e to the minus b squared, integral of minus infinity to infinity of e to the ax plus b all squared, right? Yes, carry the one, dx actually equals e to the minus b squared minus infinity to infinity of e to the y squared dy over a. How simple is that? All right, look how simple that is. That, now all we have to integrate is this, because that a is just a constant, we can take it out. Right? So what we've done is we started with this insane calculation, right, which sort of represented, as we said, it represented like this weird ass thing. And what we did, was we just made it a pure square, right? You can see we converted it into a square, and we took away this section, right? So that minus that, which is the whole square minus this, instead of having to build this whole thing, right? Instead of having to figure out each individual section, this area, that area, this area, which is stupid. You do the whole thing and you take away that small area, right? And that's all we did. And by doing that, we were able to simplify all the way to here, which is freaking awesome. So now that's all we have. Yeah, that's it. So my friends, that is the trick of completing the square. And even though that's a simple concept, right, like it's a high school based concept, see, it's like, for example, you want the area of a pizza, right, and someone's already taken out a slice. Instead of having to count the area of each slice of what's left, right, all you have to do is calculate the area of the whole pizza minus one slice. Much easier, right? How much easier is that? And we do it all the time in real life. You know, if you want to work out, yeah, that's all you have to do. So the reason that's important, even though it's simple, it actually allows human beings to solve quantum mechanics wave function equations, to calculate, you know, which quantum particles are going to go where. You know, isn't it funny? Like little simple maths. That was it. That's all I had for this lecture. I want to thank all the Patreon guys, the GoFundMe guys who've pre-ordered a copy of the book thus far. L. Brooks ordered the 7th mug today, so all the mugs are now gone. What else? We've got Gabflix, and that's the Dome Father who made the Gabflix. And the link is in the description. You can go there and there's like heaps of channels. All the channels are there, Gab Live, Gabflix. And I need to go get a new pen soon. It's going to run out. Love you guys. Have you figured the quadratic? How you figured the quadratic? Check out Gab's YouTube. It's incredible. I just love your scopes. Well, my scopes are good because you guys are here. Seriously, like if I was just talking to the wall, it would be as boring as crap. Oh, thank you, Mr. Jimmy Knapp. Likewise to yourself. Yeah, if you go to YouTube, have a look at the second live autism speech. We've sold 20% of the pre-orders of the book that I need to get it published. Who did you do the speed dating case? How did you go? Oh yeah, I didn't go too well on the speed dating case. You like math? Awesome. Well then math likes you. On Jimmy's weekly show. Well, I think what we'll do is we will all together go on each other's shows and it'll be good. We can build something bigger than all of us and remind ourselves what the hell we're fighting for in this frickin' civilization. You know, why we're still not living in bloody caves. Music show, all right. You know, I was a famous DJ 10 years ago. I sold thousands of mix CDs. Hate geometry. That means we're going to have to do some geometry. Yeah. You can go to my page on Facebook, Sydney Remix DJ. I think Facebook/Sydney Remix DJ. Yeah. I saw you doing some awesome music tracks before. Yeah. Math is music. And I'm a classical pianist by training. So, which is another weird concept. You are more than welcome, my dear Cyanide. What the good thing about Cyanide is that she's a lot smarter than when one might imagine initially. Yeah, and that's actually a good thing. It's like I feel like Cyanide deliberately wants to keep it low. Yeah, it's like you deliberately want to have people underestimate your intellect. That is my impression of Cyanide, which actually makes you more powerful. You know, in your situation. Yeah. It's it. My dad does that. Cool. I'm sort of jazz trained. All right, sort of jazz. Yeah, I get you guys. It's pretty cool. All right, I'm going. Gabversity, where facts don't care about your feelings. I'm probably going to go back to Gabsmacked and talk about some more autism stuff. Don't go. Later, fellow followed. Awesome. Likewise. No one would guess you're a chemist. That's cool. That's awesome. Awesome way to look at things. Yeah, if you get bored, go to Gabsmacked. I've got other channels, Gabsmacked, Gab Life, all on Periscope. We've got Sixlang, Sixlang, where I teach a few languages. So I'm always doing one of those channels. Hey, doing them. All right, I'm out.